Remember last time we were talking about sequences and bushels of apples. Specifically, we were talking about arithmetic sequences. An arithmetic sequence is where you take a number and you add that same number over and over again to get to the next term in the sequence of numbers. So in this case, in this example with these numbers, that D number is 2 because we're adding 2 over and over again. So we had two different formulas, recursive and explicit, and recall recursive was where we tried to find the nth term using the n-1 term. And so what that means is we're trying to find some bushel of apples way off into the future. Maybe it's the 99th bushel or the 57th bushel. But in order to do that recursively, you have to know the 98th bushel or the 56th bushel. All right. In order to find the 100th term, you have to know the 99th term. That's how this formula works. The recursive formula says I'm going to find the nth term using the one right before it, and then I would just add 2 to that. All right. So if I told you that the 99th term was 400, you'd know to just add 2 and you get 402. That's how you do it recursively. Take whatever you had previously and add 2. But for the explicit formula was a little bit more versatile because you don't need to know the one right before it. It's kind of nice. If I'm finding the 100th term, I don't need the 99th term. What you do in this case is you just take the first term, which in this example was 10, and then you're going to add that D number, which was 2, however many times. All right, so if I'm finding the 100th term, you'd have to add 2 99 times. n-1 would be 99. So for the 57th term, you'd add 2 56 times. That was arithmetic when we added the same number. Check out the difference in these numbers. Today's lesson, we're going to have numbers like this, and you should notice the pattern. It looks like this time, instead of adding 2, this time it's multiplying by 2. If you're multiplying the same number every time, that's a geometric sequence. And so we're still going to be doing the same type things. We're going to be looking for a recursive formula where we use the one right before it. And we're going to find an explicit formula where we use the first term and multiply. But we're pretty much doing the same type deal. The only difference is, the main difference is we're multiplying by 2 instead of adding 2 in this example. All right, so notice in geometric, this number is called an R number. It's a common ratio. Whereas in arithmetic, it was a D number. It was common difference. So ratio for geometric. Find the common ratio means find that number that we're multiplying by. So how do we get from this number to the next number to the next number? Well, it looks like we're just multiplying by, not 3, but -3. So we would say R equals -3. That's it. That's the common ratio. Find the next 3 terms. So I like looking at it like this. Fill in the blanks. What's next? Well, in order to do that, you have to figure out what they're multiplying by. It looks like they're multiplying by -2. So if we keep doing that, times -2 would give me -16. And times -2 would give me 32. And times -2 would give me -64. Same question. Find the next 3 terms. So again, we want to figure out what they're doing. How are they getting from number to number? Well, it looks like times 4, right? Times 4. Ooh, I don't trust myself to do times 4 on numbers this big, so let's get a calculator. 128 times 4. It's 512. And then take that number times 4. It's 2048. And then take that number times 4, 8192. Next, we want to find the recursive formula. So remember, in this case, the recursive formula, we're trying to find that nth number, or that nth bushel, but we have to use the one right before it. So for a geometric recursive, you're going to take the one right before it and multiply by that R number. So let's just see about this. We need to know that R number. How do we get from number to number? Looks like it's times -3. So that's really all we need here. The nth term is going to be the one right before it, n minus 1, times -3. That's all you have to do for recursive. So then the next one, looks like you're multiplying times 3, so the nth term is equal to the n minus 1 term, the one right before it, times 3. Find the explicit formula. So I've got the explicit formula written over there in that box right there. You take the first term times r, n minus 1 times. So, let's see. A1, we need A1 in that formula, and A1 is just this one, the first term. So we're going to have AN equals that first term times R. Well, R is how you get from number to number. It looks like that's times 4. So times 4 to the n minus 1. That's it. That's the explicit formula. What's nice about that is you can just plug in and find any term. If I want to find the 99th term, I plug in 99 into my calculator. So you look at the next one. I need to know A1, that's 3. So I'm going to have AN equals 3 times. Now I need to know R. Looks like we're multiplying times -5. To get from 3 to -15, and multiplying times -5. So let's put that in parentheses. So 3 times -5 to the n minus 1. Find the term named in the problem. I want to find the 12th term in this problem. So again, here was my explicit formula. This is what we're going to use. Okay, so for the explicit formula, just like what we just did on the last slide, we need that A1 number. A12 is going to equal that first number, -2, times the R value. How do we get there? Looks like it's times -2. So times -2 to the n minus 1. But n in this case is 12, so n minus 1 is going to be 11. All right, so that's going to be the number. Find the term named in the problem. I definitely want a calculator for this. I'm going to do -2 times -2 to the 11th power, 4096. So the 12th term, A12, equals 4096. So then the next one, remember, we're using this formula for explicit. We want to find the 11th term, so that means the n equals 11. So A11 equals the first term is 4 times, okay, looks like we're multiplying by 3 here, so times 3 to the n minus 1, well, 11 minus 1 is 10. So that's what I'm going to do, 4 times 3 to the 10th power. 4 times 3 to the 10th power. 236,196. That's a big number. 236,196. The 11th term is 236,196. Number 19, in your first week of training, you can run 0.25 miles without stopping. You double that amount each week after that. During which week will you reach your goal of being able to run a full marathon, 26.2 miles, without stopping? All right, this problem is actually easier than you might think because I'm just gonna list out the terms. I know we start at 0.25 miles on that first week, and it says we double that amount each week after that. So let's just multiply times 2, right? Double it. So times 2 is 0.5. That's the second week. And then double that 1. That's the third week. Keep doubling it. 2 and 4 and 8, 16, 32. Aha, there we go. Remember, our goal was to get up to 26.2 miles, and we can see 32 is going to get us there. So think about it. That's the first week, second week, third week, fourth week, fifth week, sixth week, seventh week, eighth week. That's where we've met our goal. The answer after 8 weeks.
In today's lesson, we're going to be talking about geometric series. You may remember from last lesson that a series is a sum. Okay, so think about what makes this geometric. Geometric is when you multiply to get to that next number. So in this case, you can see it's times 2, times 2, times 2, times 2. That's what makes it a geometric sequence. But when we're talking about a geometric series, we're finding the sum. So one thing we could do is just add up all of the terms, and if you add up all of the terms, you're going to get 93 in this example. But that might not always be the best way to do it if we have a lot of terms, or maybe we have some missing information. Luckily, we're going to have a formula. So here's the formula for the sum of a geometric series. Now notice they use the letter S, S standing for series or sum. Problem 1 says evaluate the related series of each sequence. You should try to notice this word series and remember that that means sum. We have a formula for the sum or the series. Sn equals a1 times 1 minus r to the nth power all over 1 minus r. So we can use that formula here, but honestly, it's probably going to be easier just to add up the numbers. If you just add up those numbers, -3, 9, -27, 81, -3 plus 9 plus -27 plus 81. That's really all we're doing, 60. The answer should be 60. But let's see how the formula works. In order to use the formula, we're going to need to find A1. A1 is just the first term right there, -3. And then R is what you multiply to get to the next term. So go to here, to here, to here. It looks like your R number is -3 because we multiply by -3 to get to the next number. N is just how many terms there are. Well, we can see 1, 2, 3, 4 terms. N is 4. So once you have the information, plug it into your formula. The sum of the first 4 terms, Sn, I guess, equals A1 is -3 times 1 minus R is -3 to the 4th power, all over 1 minus -3. So we can do this by hand, or it's probably going to be easier to do this on a calculator, but I would recommend you use parentheses around the denominator. Okay, or even better yet, if you said 1 minus -3 was 4, it's probably going to be even better to do it that way. So let's look at the calculator. And let's go -3 times 1 minus, and I'm going to put this -3 inside parentheses. We want to make sure -3 is inside parentheses so it can all be raised to the 4th power. Close off the top parentheses and then divide. Now, if you're going to type in the original problem, you need parentheses around that. But since we simplified and cleaned it up to just 4, that should work. Notice it gives me 60, and that's the answer. So it seems kind of silly to use that formula when it was so much easier just to add the 4 numbers together. Keep in mind, it's not always going to be that easy. You're going to have other problems where that information is not going to be given to you. So be aware. You're probably going to want to use the formula. Evaluate each geometric series described. So again, you see this word series, and you should know that series means sum. But you also see this Greek letter sigma. And remember from the previous lesson, we talked about sigma. Sigma was the Greek letter S. S stood for series or sum. And so we're finding the sum of whatever this says. So remember, what we're talking about is finding the sum of, in this case, the first 9 terms from 1 to 9. So it's like we're adding up all of these apple baskets. So think about what we're going to do here. We're going to plug in 1. And so the first number we plug in is 1. So 3 to the first power minus 1. That's 3 to the 0, which is 1. And then we would plug in 3 to the 2. We'd plug in 2, and so that's going to be 3 to the first power, which is 3. And then if you wanted to keep going, plug in 3. That's 3 squared, which is 9. And we could keep going on and on and on and on and on. But I don't want to do that. That's more work than I need to do because we have a formula for this. All right, that's the same formula that you saw before. That's the formula for the sum of a geometric series. So we don't need all of that. We don't need all 9 of those terms. We just need a few. We need the first term, because that's what it says in the formula, right? A1. And so we just did that. That's if you plug in this first number right here, 3 to the first power minus 1. That's 3 to the 0, and 3 to the 0 is 1. So we know that first number right there is going to be 1. And then R is kind of tricky, I suppose. The R value right here. The R value is just going to be whatever this base is on the exponent. So in this problem, R is 3. And then N, it's not as simple as saying it's this number right here, but it has a very big part, okay? Basically, it's how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. It won't always be this number at the top, but it will if this bottom number is 1. So you have to really think about how many terms there will be, how many terms there will be added together, and in this case, there are 9. And so anywhere you see an R, you're going to put a 3. Anywhere you see an N, you're going to put a 9. A1 was 1. So let's look at the formula here. A1 was 1 times 1 minus R was 3 to the 9th power, close parentheses, over 1 minus R was 3. Now, we're going to type that into a calculator, but be careful. When you type it in, you probably need parentheses there. Otherwise, you will not get the right answer. So let's look at our calculator. We have 1 times the quantity, 1 minus 3 to the 9th power, close them, divided by, I'm going to open up parentheses for the bottom and put 1 minus 3. Now, as an alternative to putting parentheses there, you could just say 1 minus 3 is negative 2 and just divide by negative 2 if you want, but I'm just going to do it like this and not have to do any kind of calculations at all. The number's kind of big, 9,841. Seems like it might be too big, but remember what you're doing. You're actually adding up all of these numbers. And so you're adding up a whole bunch of numbers. It's going to be big in this case, especially since this R value is 3. So evaluate the geometric series. That's what we did. Problem number 5, it's the same thing. Really just look at the formula and make sure you fill in the gaps. A1 is what you would get when you plug that in. So plug in 1. That's going to be 5 to the 0 power, which is 1. So A1 is 1. That won't always happen, but it does here. R is this number right here. And then N is how many terms there are going to be in between 1 and 8. So if you plug in 1, plug in 2, plug in 3, all the way up to 8, there are going to be 8 terms. So N equals 8. So let's plug into our formula. A1 is 1 times 1 minus R is 5 to the 8th power over 1 minus 5. Now again, I'm telling you, if you don't put parentheses there, you're going to get it wrong. So 1 times 1 minus 5 to the 8th power divided by parentheses 1 minus 5. 97,656. Let's do it again. Same things, we need the same pieces of information. So for A1, you plug in 1, plug in this number. So 2 times negative 3 to the 1 minus 1. This time it's 2 times negative 3 to the 0 power. Well, negative 3 to the 0 is 1, but you've got 1 times this 2, so you're going to end up getting 2 this time. A1 equals 2. Your R value is the base on the power. So the R value here is negative 3, and then N is going to be 9. So we have formula. A1 is 2 times 1 minus R is negative 3. I put that in parentheses. Be careful on that. If you don't put that in parentheses, you could make a mistake. To the 9th power over 1 minus negative 3. Put the bottom in parentheses or you're going to get it wrong. 2 parentheses 1 minus, put the negative 3 inside parentheses, and then raise it to the 9th power and close off the top. Divide by parentheses 1 minus parentheses negative 3, 9,842. Next says evaluate each infinite geometric series, and so your keyword here is infinite. It's kind of weird because it's like we have an infinite number of bushels of apples. We don't just stop at 6 or 8 or 9 or whatever. There's an infinite number of numbers being added together, and we've got a formula. And the ironic thing is the infinite series actually has a less complicated formula than the ones before. So it's very similar. You look at the formula and you see you need A1, and A1 is what you get when you plug in this first number. So we have negative 4 times 1/3 to the 1 minus 1. Or negative 4 times 1/3 to the 0 power. But anything to the 0 power is 1. Negative 4 times 1 is negative 4. We see that A1 equals negative 4. The only other thing we need in this formula is R, and that R number is just the base on the power. R equals 1/3. Forget about the 4 or whatever. R equals 1/3. So if we're going to find that sum, we just have to do A1 over 1 minus 1/3. If you want to use a calculator, that's fine. Just make sure you put parentheses around that expression. Negative 4 over parentheses 1 minus, I'd go ahead and put the fraction in parentheses as well. Negative 6. So it's kind of funny to think about, but what you're doing is adding up an infinite number of numbers, and if you add up an infinite number of numbers, you're going to get a sum of negative 6. We've got 2 more just like that. So find A1 by plugging in this number. 4 times 2/5 to the 1 minus 1. That's 4 times 2/5 to the 0. That's going to be 4. A1 equals 4. R equals 2/5. We should be able to plug in A1 over 1 minus 2/5. Use parentheses for the calculator. 4 over parentheses 1 minus 2/5. 6.6 repeating, or 6.67. If you did it as a fraction, that's 20 over 3. Okay, 20 over 3 is a good answer, but I would take 6.67. Next one, same thing. Find A1. That means you're going to plug in 1. That's 3.3 times 0.8 to the 1 minus 1. You've seen this enough times that that's going to cancel out, and you're just going to end up getting 3.3. Your R number is the base on that power. So you've got A1 is 3.3, and R is 0.8. You do the exact same thing. A1 over 1 minus R, parentheses, 3.3 over parentheses 1 minus 0.8, 16.5.